Good day. This is a PowerPoint about organic reactions, and so we're going to whistle through this. It may take more than one video, and it may be a little bit overwhelming. So we're going to do it this way, just get your feet wet with it, and then I will be writing out examples of organic reactions, and at that point it should make a lot of sense. So this is just to give you a taste of it, start getting your mind ready to wrap around this, but I think it will get easier as we go along. Well, first of all, combustion is one type of reaction, and it says, hey, chapter 5 is on reactions. Plus, you should know it from last year. Combustion means reaction with oxygen. So it doesn't matter if we have a hydrocarbon, if we burn an alcohol, if we burn a carboxylic acid, if we burn an ester, it's always going to be making CO2 and H2O in this game. So that's very easy. So you can see here we have one butanol, and when we burn it we get CO2 and H2O, and obviously you would have to balance the equation. That is not done at this time. Substitution reactions are a little different, and it applies to alkanes, and it can also apply to aromatic compounds. It will not apply to alkenes and alkynes. We're going to show you what they do later on. So if we take an alkane and we add something, the X2 in this case typically often is referring to a halogen, and remember they're all diatomic. And so what happens, it says you make an alkyl halide plus HX. And so what happens is, let's say this was Cl2. The molecule of chlorine comes in, and one of the chlorine atoms ends up on the carbon chain, and it replaces a hydrogen that pairs up with the other chlorine. So we could have a carbon chain with chlorine here, and then it'd be HCl is carried away. And the exact same thing applies if we're reacting with aromatic compound containing benzene. So we look at this, here we go. Our Br2 comes in, the Br is placed on the N carbons, what we said here, and one of the hydrogens here has been removed and is carried away by the other bromine. Now if we did this reaction, we're likely to get the bromines attaching to the N carbons more so than the middle, but in fact we probably get a mixture of, in this case, this is one bromopropane, but we'd also probably get two bromopropane there in some proportion as well. And here's a terrible attempt at showing it. This is benzene. Cl2 comes in. You see I've tried to obliterate the hydrogen, make a nice big Cl over it, and that hydrogen would have come away with that HCl. So one of the things to notice in a substitution reaction is when you're done, everything is balanced. We start with two things, we finish with two things, and the coefficients are 1 to 1 to 1 to 1, unless we add multiple molecules. So in other words, if I look at this one, right now there's 8 hydrogen atoms. If I added 8 bromine molecules, in fact I could replace all of the hydrogens with bromines. And so I'd end up with 8 bromine atoms attached to those 3 carbons. Now addition reactions are going to apply to alkenes and alkynes because they are unsaturated. And when we do this, what you see is we start with 2 reactants and we always finish with just one product. So earlier you would call this a synthesis reaction, but not in organic land. In organic, you better call it an addition reaction. And what happens is the geometry really matters. And I'm not going to show it very well in this PowerPoint, but I will in some future notes. These molecules have to add to the alkene in such a way that they're adding to the carbon on either side of the double bond. So you look at that, you have 2 hydrogen atoms, one H would go to one carbon, the other H to the other carbon. Here, the hydrogen goes to one, the halogen would go to the other. This represents halogen. And then when we look at water, we think of it as H and OH. Well, treat it as being ionic. So here we'd have the H and the OH would be adding, and they're going to add in such a way. So this thing, I guess we can argue we can split it like that. And so we go, okay, we get H and O, and we have H like this. So that's the original bond, and what happens is we get a bond here, we get a bond here, and then we wipe out this bond here. That's supposed to be an X wiping it out, and we wipe out one of the bonds involved in double bond. So it goes from an alkene to an alkane. In this case, if we're adding water, we've made an alcohol. Now, if we have an alkyne and we do the same thing, if we're adding 1 mole of these things, and you can see this popped around here, it should say alkynyl dihalide. My tabbing wasn't too good there. The bottom line is, if we add 1 molecule of any of these things, and it's like what we added in the previous thing to an alkane, essentially alkyne becomes an alkene with whatever we've added, creating a new beastie. So here we've added H2, and the mechanism is basically the same. So we had H and H, and what we do is we form 2 bonds. So these are the 2 bonds we formed, and then we break 2 bonds. So we break the bond between the hydrogen, and we break one of the bonds involved in the triple bond, and that's why this becomes a double bond. So in this case, our 1 pentyne becomes 1 pentane, and notice only 1 product. Now, very careful, if it says 2 moles, that means we can go from an alkyne to an alkane. We're going from a triple bond to a single bond. That's if we're adding just hydrogen. If we're adding these other things, we're still just going to single bonds, but we're going to get these different branches on it to give them different names. So here it says we had 2 moles of HF, and so what you can see, I'm saying we had H and F here, and then we had F and H here. Triple bond has become a single bond, and this is our 1 structure. Again, only 1 product in an addition reaction. Sterification we've gone through in quite a bit of detail earlier, so it says remember your earlier notes for that. Oxidation we put in for interest, but you will not be tested on it at all. So oxidation is a process that we look at in Chemistry 12 in much more detail. There are all kinds of oxidizing agents, things like potassium permanganate. And you can see, we've put an OH, and if the OH ends up on the end, if we keep oxidizing it, we can make an aldehyde. Keep oxidizing it, we can make a carboxylic acid. On the other hand, if we end up oxidizing, we make an alcohol here in the middle. If we further oxidize it, the OH becomes an O, and now we've made a ketone. Again, for interest, you might see a question on a worksheet, you will not be tested on it. So that's our introduction, and it talks about what you do for practice if you're really inclined. And I will have some worksheets on this topic, but you really have to use the notes, and use the notes in upcoming videos where I'm actually writing out what's going on, because that will show it very clearly how the game works.